All right, hey there, let's take a look at this so that it'll make a little bit more sense. We said that in order to find out what the maximum speed would be, you really need to do that at a distance halfway between the two stations, because you have to have an acceleration that can be no bigger than 1.34. So let's say that instead I accelerated for 3/4 of that distance, and then I slowed down in a quarter. My problem is I can speed up using an acceleration equal to 1.34, but when I want to slow down in a smaller distance, I'm going to have to use an acceleration that's much bigger. So let me show you how that works. So let's look up here. This would be the final speed of the train is equal to the original speed of the train squared plus 2 times the acceleration to slow down times the new distance, which is going to be pretty small. So our final speed when we slow down to a stop is 0. Our original speed would be whatever maximum speed we get with that 3/4. So to find that, we could just use this equation, but instead of 403, we would use about 200. So if I do that, if I take the 2 times 1.34, but this time multiply it by 806 divided by 4 is about, is about, let's see, 806 divided by 4 is about 201. And so we would go up 600. So I'm going to do 2 times 1.34 times, and if we're doing this 3/4, that would make this number about 600 or so. And if I multiply those and then do the square root of that, I'm going to end up with a maximum speed now of about 40 meters per second. Remember, when we did it for the whole thing, then that speed was 46.5 or so. You really want to use, for this problem, you're going to have an answer of 32.9. So you can ignore what we did at the beginning, because remember, when we did it at the beginning, we did it for the whole 806 meters, which means you instantly come to a stop, and we can't do that. So now we can plug in this original speed right here. This would be our Vmax, and that would be 40 squared plus 2 times the acceleration times the distance to stop. And that distance to stop, since 600 is equal to that 3/4 of the distance to speed up, then we'd have about 200 meters that we would have to slow down. So the key here is we're going to take 40 times 40, that'd be 1600, is equal to 400 times A, and our acceleration then would be 4 meters per second squared. And it'd be negative because remember, we're slowing down. That's too big. Remember, it said we can only use a maximum of 1.34. And the only way we can use a maximum of a 1.34 is to split this exactly in half. So that's why we can't change it to 3/4 and 1/4, or change it to like 5/8 and 3/8 or anything like that. Really needs to be just right there in half. So at that point, we do have 32.9 meters per second is going to be the maximum speed using that acceleration of 1.34, because we only want to go halfway. And once we hit that halfway mark, we're going 32.9, but then we have to slow down back to 0 again. So the key here is we have to use the same distance and the same time to both accelerate and speed up, or decelerate and slow down. And neither of these can be any bigger than 1.34. And if you split it any other way, one of them is going to be bigger than our limit of 1.34. So that's kind of why you see it. The rest of the problem then I think makes sense to you from what I kind of saw on the on the texts. So you should be good at that point. And I think that's it.